Lunar lander China has its eyes firmly set on the moon, and they're not shy about it. The country's space agency has announced plans to land astronauts there before the decade is out. To back up that claim, they've already begun testing their brand new lunar lander, nicknamed Lanyu, which translates to embracing the moon. And yes, it definitely looks the part. At first glance, you might notice it has some similarities to NASA's Apollo-era lunar module, but there are also some major differences. The Apollo lander was essentially two spacecraft stacked together, a descent stage on the bottom to land and an ascent stage on top to launch the astronauts back home. China's design, however, appears to be a single-stage vehicle that handles both landing and takeoff. One of the clearest test videos we've seen shows the lander firing its engines at night. There are 4 main thrusters surrounding the crew cabin, plus an outer ring of small reaction control jets near the landing legs to help keep it stable. Unlike Apollo's single big engine in the middle, this setup uses multiple engines in a redundant configuration, meaning if one fails, the others can still safely bring the astronauts back into lunar orbit. Now, about that giant rig of towers and cables around the test lander, what's going on there? 2 things. Safety. If the lander malfunctions, the rig ensures it doesn't smash into the ground. Moon simulation. Since lunar gravity is just 1/6 of Earth's, the cables help offset about 85% of the lander's weight. They also cancel out things like wind resistance, which obviously doesn't exist on the moon. It's actually a pretty clever setup, and one China has used before, like when testing their Tianwen-1 Mars lander. From what's been shared, the tests appear to have gone well, though Chinese officials haven't released specific milestones or a detailed timeline. What we do know is their target, astronauts on the moon before 2030. Of course, the lander is only one piece of the puzzle. China is also developing a new spacecraft called Mengtian, which will carry astronauts from Earth to lunar orbit and back. A prototype was tested just last year, including a suborbital flight and a successful test of the emergency abort system. The race to the moon is heating up, and China is making it clear they're serious contenders. Unlike NASA's Apollo days, China isn't planning to send everything to the moon on a single rocket. Instead, their mission will use 2 separate launches, one carrying the Lanyu lander, the other carrying the Mengzhou cruise ship. Both will meet up and dock in lunar orbit before heading to the surface. The heavy lifter for this job is the Long March 10A, a brand new rocket still in development. Picture something that looks a lot like a SpaceX Falcon Heavy, a triple-core booster, each core powered by 7 liquid-fueled engines. China hopes to launch a single-core version of the Long March 10A for the first time within the next year. Alongside the rocket work, China has been showing off other pieces of their lunar toolkit. About a year ago, they revealed the first design for their new lunar EVA suit, called Wangshu, and they're also developing a lunar rover nicknamed Tengyun, essentially an electric dune buggy for astronauts to drive around on the surface. Out of all the challenges, that rover is Probably the simplest part of the mission. So yes, China is making steady progress. The hardware looks real, the tests so far are working, and the momentum is undeniable. But the big question remains: can they really pull off a full crewed lunar landing before 2030 and, more importantly, bring everyone home safely? That's the true test. And speaking of ambitious timelines, Rocket Lab is also racing ahead with its own big leap. CEO Peter Beck recently told investors that the company is still aiming to launch its brand new Neutron rocket in 2025. This is a huge deal for Rocket Lab. Their current workhorse, the Electron, has been remarkably reliable, 65 successes out of 69 launches, but it can only carry about 300 kilograms to low Earth orbit. It's a small rocket, but it's been a great test bed for innovation, from its carbon fiber body to its 3D printed Rutherford engines powered by electric fuel pumps and lithium batteries, the first of their kind. The Neutron, on the other hand, is a giant leap forward. It's a much bigger, fully reusable booster designed for propulsive landings, either on land or on an ocean platform. Even the cargo fairing is unique. Instead of separating and falling away, it opens like a clamshell and comes back down attached to the booster, ready to be reused. Just last week, Rocket Lab successfully fired up the Archimedes engine for the first time. Beck stressed that this wasn't just a prototype, it was a flight-ready engine pushed all the way to full power in a long-duration burn. From here, the plan is simple: fine-tune the engine, mass-produce it, and get Neutron ready to fly. Rocket Lab still says they're on track for a first launch in late 2025, but as Beck himself admitted, that depends on absolutely everything going right between now and then. Peter Beck has been crystal clear about his priorities. Mission success comes first, timelines second. On Rocket Lab's earnings call last week, he said, "We're not going to rush and take stupid risks just to launch Neutron before it's ready." In the grand scheme of a rocket's life cycle, being a couple of months early or late is completely irrelevant. He stressed there will be no cutting corners just to hit an arbitrary deadline. That might have been a subtle jab at SpaceX, who launched their Starship for the first time on April 20th, totally not intentional, of course, and ended up blasting a crater into their launch pad before the rocket suffered multiple engine failures, spun out of control, and exploded mid-air. Elon Musk still called that a successful test, but Beck wasn't having it. He said flatly, "You're not going to hear some rubbish about how just clearing the pad is a success." For us, success means Neutron actually reaching orbit. Now, Rocket Lab is realistic too. The first booster landing attempt won't be picture perfect. Best case scenario, Neutron's debut flight ends with a controlled splashdown in the Atlantic Ocean. Beck admits recovering and reusing the first stage will be a learning curve. Another big difference for Neutron is its launch site. Instead of Cape Canaveral, Rocket Lab built an entirely new pad at Wallops Island, Virginia. The idea was intentional: spread out America's launch capability. If something catastrophic ever grounded Cape Canaveral, the US would essentially be stuck. Having another spaceport adds resilience, which is especially important now. And speaking of national security, Rocket Lab sees a huge opportunity for Neutron. They're eyeing involvement in the Pentagon's Golden Dome missile defense program, a $175 billion project that could be one of the largest US defense procurements ever. Beck said Rocket Lab is in a great position to take part. It's no coincidence then that Rocket Lab just bought Ghost, a company specializing in missile warning, tracking, surveillance, and space awareness tech. The deal was worth $275 million, with $125 million paid in cash and the rest in Rocket Lab stock. This move puts Rocket Lab in a strong spot to blend defense, security, and launch services into one package. That pretty much checks every box for Trump's Golden Dome program, which means Rocket Lab could become a one-stop shop for space defense, providing both the rockets to get hardware into orbit and the orbital platforms to run the missions. But Peter Beck isn't stopping there. He's also looking at giving Rocket Lab a role in the offensive side of military tech. Instead of retiring their small Electron rocket, Beck wants to reimagine it as a missile. The program is called HASTE, Hypersonic Accelerator Suborbital Test Electron, and its first test flight took place in June. The company stayed tight-lipped about what payload was on board, how fast it went, or how high it flew, but they did confirm that the mission was a success. In this configuration, Electron can carry a 700-kilogram payload on a suborbital trajectory, which basically means it takes off and then comes back down somewhere else on Earth. What could they deliver with that? A bomb? A supply drop? Some kind of sci-fi weapons platform? No one outside Rocket Lab really knows. But it's clear they're making a bold pivot into military applications, and it shows Beck is playing a much bigger game than just commercial launches. So yeah, something big is definitely brewing at Rocket Lab. Stay tuned. We'll be keeping a close eye on it. And hey, if you love tracking the fast-moving world of spaceflight, consider supporting the channel. Your support fuels our curiosity and keeps these deep dives coming every week. We're taking a short break to give our writer a well-earned vacation, but don't worry, we'll be back stronger than ever in September, with our regular weekend videos still rolling out in the meantime.